Hey folks, just making sure my volume's up. This is our last review for our final. So we have a couple of proofs here. I think we have three proofs actually. So anyway, so let's go ahead and get started. So the given says that they bisect each other. So this segment bisects this segment and vice versa. So when they bisect each other, they cut them into equal segments. Okay, so make sure you mark it so you can see how we're going to get side angle side. Okay, so what I'm going to do is get this triangle congruent to this triangle, so I can say this angle is congruent to this angle by CPCTC, and these are alternate interior angles, and when they're equal, these lines are parallel. I'll show you that in just a second. Okay, so anyways, by definition of a bisector, this side equals this side and this side equals this side right there. And then these vertical angles are equal. So don't say angle E because there's more than one angle there. We have to say angle HEP and REC. Okay, and then the triangles are congruent by side angle side. And then you can say either this angle right here and this angle. I think I chose this angle and this angle right here. So we'll say those angles are equal. And once those angles are equal, then we have these lines cut by this transversal. If the alternate interior angles are equal, then these lines have to be parallel. And that's what we're trying to prove right there, okay? All right, so here we're going to get triangles congruent again and use CPCTC again. Let's go ahead and say the right angles right there, and then notice we marked them right there. So that's from the given right there, and so we're going to do, let's see, so AB, this other given, here's AB. See this hypotenuse of this right triangle? Well, let's state that they're right triangles. So we can use the HL theorem. And we can use the reflexive property, that BD part. Okay, so there's the next given, there's the reflexive property, so now they're congruent by HL and everything's congruent by CPCTC. Okay, all right, so this guy here, let's put that down, and then I think it's best before I'm not even going to distribute because we'll get a fraction with this A right there. Let's get rid of this 1. Let's do -1, -1. So -2 minus 1 is -3, so subtracting 1. Now multiply both sides by 5, okay, and it gets rid of that 1/5. Okay, and then we'll subtract 10, and there's our answer right there, okay? All right, so this says simplify. Okay, I'll show you the way that I teach this, and then I'll show you a quicker way, and then we'll use the quicker way from now on, okay? All right, so the way that I teach this is to get the prime factorization, okay? First pull out the I, so we have 5I root positive 43, because the square root of a negative means it's going to be an I. Okay, because the square root of -1 is I. That's what I stands for, is the square root of -1. So whenever you have a square root of a negative number, it means there's an I involved, okay? So it's I root positive that number. And then we get the prime factorization of 48. Do you remember factor trees? So if we broke it down and got the prime factorization, we get 4 2's and a 3, okay? And then these two 2's come out as 1, 2. These two 2's come out as 1, 2. So we multiply those with the 5i on the outside. Okay, so 5i times 2 is 10i, times 2 is 20i, so we get 20i root 3. Here's another way, you guys, okay, and this is the way I'm going to do it from now on, okay? If you know perfect squares that goes into this number right here, 16, I know 4 goes into 48, but so does 16. That's a bigger number, 16 times 3. And the square root of 16 is 4. That's where this 4 comes from right here. And there's the root 3 right there. That's the quicker way. That's the way the pre-calculus kids do. And I want to encourage you guys to start doing this because you guys are going into integrated math 3. And so that's the way as IM3 students are going to do too. All right, so here's the square root of 16 is 4. So 5i times 4 is 20i. Okay, same answer. And that's the way I'm going to do that for the rest of these right here. Okay. All right, so let's pull the i's out. This is going to be 3i root 8. This is going to be 2i root 50, okay? And then notice I changed 8 to 4 times 2, 50 to 25 times 2, and these are perfect squares, okay? The square root of 4 is 2, square root of 25 is 5, okay? So there they are. They get pulled out right there. So this becomes 6i. This is 10i, and we can add those because they have an I, they both have an I, and they both have a root 2, so we have 16i root 2. Okay, all right, this guy. This is 9 times 3. Again, this is 16 times 3. This is 16 times 2. And we're using the 16 because they're perfect squares. And the 9, that's a perfect square. Square root of 9 is 3. Square root of 16 is 4. The square root of 16 is 4. Okay, so we're left here with 2 times 3. This is 2 times this 4 right here. So this is going to be 6 root 3. This is going to be minus 8 root 3, and then plus 4 root 2. Okay, treat these like variables. These are like radicals. This is not a like radical, so I can't do anything with this, but I sure can subtract 6 root 3 minus 8 root 3. This is negative 2 root 3. And this is positive 4 root 2. So we write the 4 root 2 first. So here's the minus 2 root 3 from these two guys right there. Okay, that looks cleaner than writing negative 2 root 3 plus 4 root 2. Okay, all right. Okay, so here, let's go ahead and distribute that 5i through. Okay, so we get 10i squared minus 20i. And remember, I squared is negative 1, so 10i squared becomes negative 10 minus 20i. Okay, going to FOIL these out and FOIL these out at the same time. Okay, so there they are right there. And if you cleaned it up, we get that answer, and clean that up, and we get that answer right there. These guys are called conjugates of each other. Do you remember that trick? The trick is square this one, and subtract them, because the outers and inners will always cancel out. So 16i squared minus 1 becomes negative 16 minus 1, which is negative 17. Okay, the outers and inners on conjugates always cancel each other out. Okay, all right, I'll do these simultaneously, solve by completing the square, because we did this in one of our other ones. I think it was worksheet 1, I think, completing the square. So let's get rid of this 80. So we'll minus 80, minus 80. We'll minus 30, minus 30 right there. There we go, right there. Okay, and let's clean that up right there. Okay, and then this is where we take half of this number squared, and we add it here and add it here. So half of 14 is 7. 7 squared is 49. So we'll add 49 here. So to balance it out, we'll add 49 over there. Half of 22 is 11. 11 squared is 121 here and here. So that's what we're going to do on both of those, okay? All right, so this side becomes x minus 7 squared, and then this side becomes negative 39. Over here we get x plus 11 squared equals 96, okay? So when we square root this side, we get plus or minus the square root of this side. The same on this side right there. Okay, now we're going to pull an I out, and 39 is 3 times 13, so nothing comes out. This is 6 times 16, I'm sorry, yeah, 16 times 6, so and 16 is a perfect square, so we'll write it like that right there, okay? All right, so here this is going to be 4 root 6, okay, and then here we'll go plus 7, and after we make this 4 root 6, we'll go minus 11, and so there's our answers for both of those guys right there, okay? All right, so here, parallel lines cut by a transversal. We've done these lessons before, so I'm going to do this all in one step. Those guys are supplementary, so we should get 35 right there. Adds up to 180. All right, so this line is here as a deception. It doesn't want you to see these vertical angles right there. They're equal to each other. You should get 16 on that. All right, okay, so on this one here, I won't do this one all in one step. So if this is 71, then this is 71, because these two sides are equal right there. So let's put that 71 right there. And then here's a triangle, adds up to 180. So this is 142, so this must be 38 right there. And then 38 plus blank equals 90, so this has to be 52 right there. So if that's 52, and if these two sides are equal, then this has to be 52, because that's 52 right there. So x equals 52. All right, so this one, this angle equals the sum of these two guys. So if we let that equal the sum of those two guys, it's called an exterior angle. Exterior angles equals the sum of the two remote interior angles, and I got 10 on that guy, okay? All right, so this one here, This right angle tells me that this angle plus this angle equals 90, so when we add those up we get 19 right there. And then here these two angles, because of the straight line, equals 180, and I think I got a fraction on that, so yeah I did. So there's the answer to that one. Alright you guys, take care.